Hello everyone, my name is Jiang Zixin, and today I'll be presenting my research and evaluation of predictive resource allocation strategies for server load forecasting. We've all experienced the frustration of a website freezing or a service lagging. This is often caused by inefficient reactive auto-scaling. That means that the server only adds more resources after the system is already overloaded. This leads to high user wait times and, alternately, waste money on idle resources. My research tackles this problem by asking what is the most effective proactive strategy to predict server load even before it happens. To find the answer, I built a custom simulation framework in Python. This simulation mimics a real-world server, including an off-peak period for training and a sudden peak period surge to test responsiveness. To measure performance, I created a penalty-based scoring system where a low score is better. The most severe penalty was given for user wait time, followed by penalties for wasted resources, and then the cost of making reactive changes. I then compared a range of strategies, baselines like basic and moving average, statistical models like ARIMA and linear regression, machine learning models like LSTM and the transformer-based informer. But I didn't just test existing models. I introduced two key innovations. First is the FFT strategies. That stands for Fast Fourier Transform. Instead of treating server load as a simple trend, I treated it as a complex signal. I used the fast Fourier transform to identify and predict the dominant periodic cycles, just like a daily rush hour. The other innovation is the cleanse mechanism. This is a hybrid model that can be added to any strategies. It has two parts, a proactive part that uses the model's forecast and a reactive part that checks the current server queue and adds just enough resources to clear any existing backlog. So where are the results? This result is from a pool of generated users. As users' amount increases, the gap between simple and advanced models widens significantly. Advanced models scale more cost-effectively than the baseline. Also, cleanse is universally better. The cleanse counterpart is better than the same strategy without using cleanse. Also, I test from some real-world data. The left picture is the real-world data, and the black line is the actually user load, and other color lines are predicted from different strategies. So, in this graph, it seems like some active ones are doing better. And the right-hand side picture is the score from different strategies. So, it seems like FFT strategies are doing best. Also, we can see that using cleanse is better even in the real-world data. To further confirm this result, I use another set of real-world data from Cargo. It shows the same result. In conclusion, my research demonstrates three key findings. First, predictive strategies are superior to simple reactive methods because the predictive strategies minimize cost and maximize service quality. Second, the application of fast Fourier transform to server load is highly effective. It successfully identifies complex periodic patterns that other models may miss. Last, cleanse is critical for latency. The hybrid proactive plus reactive model is the key to real-world success. This mechanism is crucial for adapting to immediate spikes and eliminating user wait time. By combining these strategies, we can create cloud systems that are not only cost-effective but also highly responsive, ensuring users get the seamless experience they expect. Thank you.